Hey y'all, hope you're doing well. This is 7.7 Scale Drawings and Models. Remember, you can stop and start this video at any time, so you may want to stop it to write down the vocabulary and then continue in just a little bit. So a scale model is an object with lengths proportional to the lengths of the object it represents. So sometimes when car companies are going to make a new car, instead of making a full-size model, they might make a smaller car model to make sure they have everything proportional before they make something that is bigger. So that's just an example. A scale drawing is a drawing with lengths proportional to the object it represents, and when I think of scale drawings, sometimes I think of like blueprints of a house being built, or maybe the front of a house or something like that is a scale drawing, but there's plenty more. And then scale is similar to the scale factor, but it is a ratio of the lengths on models or drawings to the actual length on the object being modeled or drawn. So remember, that to word is going to be important, and we'll look at that in just a second. Alright, let's see. Use scale drawings, and we're going to use it in maps because that is a lot of times what you'll see. So the distance between Boston and Chicago on the map is 9 inches. So Chicago is here, Boston is here. So when I get out my ruler, which you will need tonight, that is going to be 9 inches. If the scale of the map is 1 inch is 95 miles, then a lot of times you'll see that kind of down in the corner. It would be like 1 inch equals 95 miles. You might see something like this much equals 100 miles or something like that. That's just an example of your scale. What's the actual distance between Boston and Chicago? So there's two methods. We're just going to use one just because I think it's pretty explanatory. So I'm going to put my map over my actual distance. So I need to stay consistent with what's on top and what's on bottom. So I'm going to say, use my scale, 1 inch is to 95 miles. That's going to equal, and I'm just going to set up a proportion. Because my map is on top, I'm going to use 9 inches on top is to x. And that's going to be left in miles since my my bottom part is in the miles. So to solve, I'm just going to cross multiply, and I'm going to get x equals 855 miles. Again, because x was what was left and I'm solving for, I'm going to use that miles as my units. Alright, let's go to the next page. Go ahead and do your checkpoint really fast. Alright, I got 720 miles. Hope you did too. We're going to keep on moving. Find the scale. Alright, so a miniature replica of a fighter jet is 4 inches long, and when I have information, I just go ahead and underline it or circle it. You might notice that, but an actual jet is 12.8 yards. What is the scale of the model? So we are trying to find this many inches equals this many yards, or whatever it may be. To find the scale, write down the ratio of a replica, or the model, you could say. Let's put model since we're using that word. Of the replica at length to an actual length. So I'm going to put the replica or the model on top. Over the actual length. So I'm going to say 4 inches over 12.8 yards. And I'm going to leave my units because it is a scale. I'm going to simplify. So I'm going to get 1 inch equals 3.2 yards. And unlike scale factor, scale can have 2 units. So that is how they are different. Scale factor, remember, is just 1 over 2 or something like that. Scale can have 2 units. Alright, so portion B, a miniature replica fighter jet is 4 inches. The actual is 12.8, what we just found. How many times as long as the actual is the model jet? So we need to find the scale factor when I'm looking at how many times. And remember what we just talked about, scale factor has the same units or no units. If they have the same, they would cancel. So to get the scale factor to a unitless ratio. So that's what that means. Alright, so we need to get our scale, what we just had. So we already used it. So 1 inch is to 3.2 yards. And to get unitless, we are going to have to convert. So we know that we have to know how many yards. So if yards are on the bottom, I need to put yards on top. Inches, I need to put inches on the bottom. You could do yards to feet, feet to inches, whatever you want. So I know that there's 1 yard to every 36 inches. I could have also said 1 yard to 3 feet, and then did 1 foot is to 12 inches, however you want to do it. Alright, so because my units cancel, then I'm going to multiply across the top. So I have 1 over multiply across the bottom. 115.2 would be my scale factor. So that means my scale factor is 1 to 115.2, which means that my actual jet is 115.2 times as long as my model. So that's what the scale factor means. Alright, go ahead and stop this video and do your checkpoint. This one is important because it will be assessed later. There are your answers. And we'll move on to the next page. Alright. So, Jared is making a scale model of his classroom on an 11 by 17 inch sheet of paper. If the classroom itself is 20 feet by 32 feet, choose an appropriate scale for the drawing and determine the drawing's dimensions. Alright. So, I know the actual classroom is 20 feet. So I'm going to take my actual 20 feet and I'm going to divide it by, I have to put 20 feet on 11 inches because that's my shortest. So I'm going to divide it by my shortest length, so I'm going to put 1.8 feet here, and we'll get to what that means in just a second. 1.8 feet per inch. Alright, so I'm going to take my other dimension, 32 feet, and I know 32 feet has to fit into 17 inches, so how does that fit best? I'm going to divide it by 17 inches, so I get 1.8 feet per inch. Alright, so what does all that mean? Why did we do all that work? Alright, so a scale of 1 inch equals 2 feet will be appropriate. So for every 1 inch, 2 feet. So I'm looking at this 1.8 and 1.8. So if I make every inch of my paper represent 2 feet, that would fit in both of my width and length. So I'm going to take, well, I just did this, I'm going to take those two numbers and I'm going to round up. So both fit on my paper. So if one was 1.8 and one was 1.5, I'm going to use my bigger number just because I need both of them to fit. And then I'm going to round up because I don't want to think about 1.8 feet per inch. So I'm just going to make this scale be 1 inch equals 2 feet. If it was 2.5 and 2.3, I can either, I'm going to use my bigger number, so I can either keep it as 2.5 just because that's easy, but I would probably round up, so that would be 1 inch is to 3 feet, or whatever your units are. Those are just some examples. So for every 1 inch of my paper, let the actual be 2 feet. So what does that really mean, and how much is my new dimension? So write an equation. So how much paper are we going to take up? So my actual equals my scale times the inches on my paper. See if they fit. If my scale that I picked will work. Let's check. So my width, I'm going to say 1 inch, my scale, over 2 feet. Is that equal to x over 20 feet? So cross multiply, 2x equals 20. Divide, so I would say 10 inches. Well, 10 inches fit on 11 inches. That is correct. So I'll have 1 inch left over. Alrighty. And I'm going to do 1 inch, my scale that I created, over 2 feet. That's going to equal y, my width, over 32 feet. Cross multiply, 2y equals 32, so I would have it 16 inches long. Does 16 inches fit on 17 feet? Absolutely. I'm going to have 1 more inch left over on there as well, so my scale will be 1 inch is to 2 feet. And my new dimensions will be 10 inches by 16 inches, which is the model of the classroom. Alright, just so you can make sure you know how to do this one, again, it will be assessed. Go ahead and stop this video and do your checkpoint. Alright, and here is the solution. So if you notice, if I have a scale and I use my scale correctly, I know that this scale would be accurate to be able to fit my 84 feet by 144 feet onto a 15 by 26 inch display. So hope you learned something today about scale models and drawings, and we'll see you back here next time.